everyone today for the third and final presentation in our Urban Agriculture Pest Management webinar series. This webinar series is coordinated by the Great Lakes Urban Agriculture IPM Working Group, and this work is supported by the USDA National Institute of Food and Agriculture Crop Protection and Pest Management Program through the North Central IPM Center, and we thank them for their support. The presentation today is being recorded and will be sent out by the end of the day Friday. This will be our big summary email with all of the links that have been in the series, of the recordings that have been in the series so far. So you'll have access to all of our webinar recordings at that time. Please note that the presentation links that will be in that email are only good for 60 days past the recording date. So if you are planning to use those, make sure you do that within that 60-day window. Okay, just to give you a quick Zoom orientation for today. Our settings are going to be a little more flexible. So we do still want to have that webinar quality, but there may be some instances throughout the presentation where we ask for your interaction. So just know, please stay muted and keep your video off until those times during the presentation. But at any point you can use the chat box to communicate with me if you're having technical difficulties or if you have questions. We will likely hold those questions till the end, where we'll have some question and answer time at that point. Okay. Hold on one second. Let me just do some administration. Okay. All right. So I think that is all of our announcements before we get started. So I do want to introduce Farnanda Krupek. Farnanda Krupek is an assistant professor and urban food systems horticulturist at The Ohio State University in the Department of Hort and Crop Sciences. Dr. Krupek recently completed her PhD in crop physiology and production at the University of Nebraska-Lincoln. She obtained her master's from the University of Florida, and Fernanda is from Brazil, and that's where she started her studies in plant sciences. So Fernanda, I'll turn it over to you if you want to add anything to your bio or your history, but please take it away.
Thank you so much, Maggie, and good afternoon, everyone. For those on the Eastern time zone, I would say good afternoon, but it can be good morning too. Thank you so much for the introduction. I would like to thank you, the North Central IPM Center, and also the Urban Ag Working Group for the opportunity to be here today sharing with you all about cover crops, which has been the focus of my work over the last, I would say, 3 or 4 years, just prior to joining Ohio State. So some of the highlights of what I'm proposing here today for us to discuss, we are going to start with a quick introduction about urban agriculture, which is the role that I'm here at Ohio State, and then focus on a couple of different aspects: cover crops and food crop production systems, broad overview, and more specific, looking at weed management standpoint, also soil organic matter dynamics, and disease reduction. And at the end, I would like to propose here some sort of practical here, where we are going to actually use a cover crop recommendation to for those that are interested in exploring cover crops in their fields. So what is urban agriculture, right? Production of food in urban and suburban areas. As you can see here, this infographics that some colleagues at University of Florida put together. You see here a huge spectrum of production methods, technology, and also opportunities, right? And you can categorize urban agriculture in different ways. One of the things that I like to think about it, it's 4 broad categories you are seeing here. So for example, urban farming, where you have food production for sale or market gardeners. You can also look at urban agriculture through the lens of community gardening, market gardening, and backyard gardening. Well, a little bit of background here in Ohio. Urban influence in Ohio, largest cities, as you see here in this map and the graph as well, the largest county and largest cities in Ohio really brings a lot of opportunities. And I would say forming aspects that it's really important to consider when looking at urban agriculture in terms of the scale, right? Those cities have huge population density. In terms of complexity, all the influence of multiple jurisdictions. Also, in terms of the diversity of residents, the workforce, and community partners, right? And also that urban to rural gradient. Ohio is a big agricultural state, and in some of those counties, you see that urban to rural gradient aspect. So we know that about 15 to 20% of vegetable and post-crop production actually happen in urban and peri-urban areas, which really have the potential to feed a significant portion of the population, right? In terms of most common production practices, I really like to show this recent publication that some colleagues at Purdue University put together looking at the demographics of Indiana urban agriculturalists. So you see here all the most common production practices: high tunnels, floating row covers, supported raised beds, greenhouses, raised ground beds, container gardening, and vertical growing. One aspect that this publication also identified was what are some of the challenges that those urban agriculturalists are facing. So you see here the top 7 challenges, all those related to insect pest identification, plant disease, marketing and business, soil health in terms of nutrient, soil pH and amendments, nutrient management for plant health, weed identification or management, and irrigation. So in general, if you look at those challenges and some of the overarching theme of those challenges, right, they somehow fall under the umbrella of integrated pest management. So when we think about integrated pest management, there are different tactics, right? We can look at more a preventive way, let's say cleaning planting materials or all that monitoring and early detection. We can also think about biological aspects using any sort of biological control. There's also the chemical aspect using sorts of pesticides. There is also physical aspect of integrated pest management. So for example, looking at row covers, anaerobic soil disinfestation, biofumigation, and finally, the cultural practices. So we can think about compost and organic amendments, cover cropping, crop rotation, resistant cultivars, grafting. So for the purpose of my presentation here today, as you saw in the topic, we are going to cover cover cropping. And I really like to see cover crop as a valuable tool for growers, right, to add as part of their integrated pest management plan. And in general, cover crops have received increased attention and also popularity from home to community gardens to commercial vegetable production operations. Well, I really like to do some analogies here. Every time I think about cover crops, it reminds me back when I was young in Brazil, growing up and actually seeing my parents getting rid of their vinyl records because they didn't want that anymore. And I found myself recently actually buying some vinyl records. I like to do this analogy because I see cover crops really as that revival of historical soil management practices, right? It's not something new. But there's a lot of documentation, even indigenous communities using cover crops. So that's sort of the analogy I like to make, really thinking about that reviving of prior practices. Now, I would like some of your inputs here that will help the discussion and the presentation today. How would you describe your cover crop journey? So if you can please take the time to scan this QR code, and it will take you to the question that you should be able to answer. And I will give a few minutes here so we can start getting results of the survey. Yeah, how would you describe your cover crop journey? Have you used it before? You never use it? You're new to it? So it seems we have lots of people that never use it, new to it, use it in the past. So I'm getting some answers. Thank you for taking the time and answering that. So apparently we have 43% here saying never use it, 29% new to it. Awesome. Yeah, thank you for taking the time to answer. I do have a second question for you, and that is since, let's say, most here, it seems, never use it, regardless of your level of experience, what is your top unanswered cover crop related question? So any general question that you came to this presentation today, really wanted to find an answer, or something that intrigued you when you think about cover crops. So let's give a few more seconds here so we could start seeing what are some of the unanswered cover crop related questions. Do they make insect pests worse? That's a great question. What else? Best plant seeds to use. Can you turn a cover crop back into the soil? What plant makes for overwintering? Will it help with reducing weeds and asparagus? Different crops available in seasonality. Interplanting. What to do after termination? Yeah, lots of great questions here. Effectiveness and best approach for a small home garden. Amazing. Yeah, well, let's try to tackle some of those answers here. If I'm not covering that throughout my presentation today, I'll be happy to take questions at the end and also be available at any time after the presentation to discuss this. But yeah, all great questions. So let's focus on cover crops and specialty crop production systems, right? This is the second topic I'd like to cover here today. So we know that fruits, vegetables, and horticultural crops are increasingly important to our agricultural system and food security. And they are also vulnerable, right, to climate-related problems that cover crops can help to address. When we look at the literature, we have far less research that has been conducted on cover crops used by farms who grow mainly vegetable or food crops, right? Compare, let's say, to much of that large body of the research on farmers who are primarily row crops. So what you are seeing here in this table are some of the results of a survey data from fruits and vegetable growers in Ohio and Michigan, really characterizing the cover crop use, the types of cover crop used, and the multiple times. So you see here, when looking at all the farms, some of the types of cover crops, basically categorize them in legume cover crop. You see that veg, clover, and peas, grasses, rye, barley, wheat, sudden grass, and oats, and also brassicas and buckwheat. This study, this survey also showed in terms of farm size, right? Different farm size, what are some of the different cover crops that they are using, and whether or not those farms are certified organic impacts, or inorganic farms. So really having this opportunity to see what is going on in terms of cover crop adoption in Ohio and Michigan. Now, cover crops are being adopted in vegetables, more in vegetable, I would say, compared to fruit crops. This is what this study has been showing. And also, adopting cover crops are more likely those growers to use 3 or more crops. So that is what you are seeing here in terms of usually more cover crop adoption among vegetable growers, and usually 3 to more cover crops in their rotation, right? So if we think about vegetable growers using 3 or more cover crops, it can be really hard, right, to make cover cropping a priority in the midst of a more pressing demand of a vegetable farm, right? So how do we start that? And I would like to think about first in terms of your succession planting plans, right? What is succession planting? After one of your crop is harvested, then another is planted in the same space. And this provides that continuous supply of the vegetable crops that you are growing. Now, what effects succession planning has? So a couple of key factors to consider here: length of your growing season, the climate where you are, the crop selection, and the crop rotation should be factored in. So thinking on your succession planting, items that you would consider, right, as you are growing your vegetables. The growth habits, the spacing, do you need trellising? Are the crops spreading? Are you talking about warm and cool season? Crops, frost tolerant, heat tolerant, days to maturity, how long from seeding to transplanting or transplanting to harvest, and also the length of production cycle. So thinking about those crops that are single harvest, very short cycle, for example, radish, or those crops that have long continuous production like tomatoes, or those crops with long cycle but harvest at the end, for example, winter squash. So all those things are in consideration when considering succession planting, right? And we know that crop rotation is key for those successive plantings, and especially like vegetables that belong to the same plant family. They share same of the many pests and diseases. So this is something to keep in mind. So on a basic level, we want to avoid planting the same vegetable or its relative in the same spot for, let's say, 3 to 4 years. Now, you think on your succession planting, and then how do you integrate cover crops on that, right? So a simple way to look at your cover crop is to base your decisions based on the timing of your cash crop. So loosely, you can group your cash crop as early spring crop, warm season crops, fall season crops, right? And then you can manage your fields, let's say in blocks based on your harvest time. So you can free up sections that can quickly be seeded into a cover crop depending on the time of the year. So that I also want to emphasize here some aspects of that you consider as a target crop, but also looking at the cover crop growth cycle and plant architecture. So you see here this cover crop chart that has some of the major grasses, broadleaves, and legumes cover crops. So you can look at the plant architecture to really help understand how that can feed on your succession planting, right? There is also this source from the University of Minnesota Extension where they put together some cover crop options for vegetable growers. So you can think about, let's say, in fields where you will plant early spring crops, let's say melon, cucumber, lettuce, or peas. Some of cover crop options that you can consider are oats and pea mix, and those they will winter kill, so the residue is relatively easy to incorporate in the spring for early plants. You can also consider for those early planting crops, let's say tillage radish, which is great for breaking up soil compaction, scavenging nitrogen and adding that biomass. But like I mentioned before, you need to consider that as a system, right? So how do you consider that in the rotation? So for example, tillage radish would not be recommended as a cover crop following or preceding or adjacent to a brassica crop, right? Because it can really harbor some of the same insects and diseases. Well, the concept of cover crop growing between cash crop is one of the most used ways, right, that we have seen the literature for cover crops. But if we think about the concept, the aspect of urban agriculture, the challenges in terms of soil remediation considerations, the lack of enough space to grow their crops. So that's where we see opportunities here for polyculture, where you have cover crops interseeded with your cash crop. So I just want to emphasize here a recent study really interested where they look at different cover crop species. One that is very common, white clover. Could that be planted with as a polyculture system with tomato and actually help with phytoremediation? So it's a very interesting study that has been looking more at that opportunity for polyculture. So, and we know, for example, white clover, in other studies, there has been results showing that can reduce levels of cabbage aphids, for example, right? So really looking at that polyculture aspect as an opportunity, especially in urban areas where we have limited space and sometimes some challenges in terms of soil remediation. Now, this was the main terms of specialty crops production system, right? I want to focus now this part of the presentation really looking at cover crops as a weed management tool, especially the possible mechanisms behind it, and a couple of studies that highlight this aspect of cover crops. So most of the cover crop related studies focus on the above ground biomass, right? How much cover crop growth or that living mulch we need to suppress weed emergency. I would say a lot less is known about as far as weed seed bank, right? And that interplay between cover crop and seed dormancy. So you're seeing here a recent study looking at what are some of the possible mechanisms here that cover crop affect weed seed banks. So cover crops, we know, alter the soil environmental conditions. So for example, temperature, moisture, light, oxygen, nitrogen availability, all those aspects you are seeing here, that's where cover crop are critically influencers of seed dormance and germination. So just to give an example in terms of light, light is an important aspect that drives the presence or absence of plant canopy to seeds. So for example, light is required to break seed dormancy and promote or inhibit germination in some species. So we know that an actively growing cover crop will most likely reduce that overall light quantity getting to the soil and that red to far red light ratio. So really helping to reduce some weed germination. Now, that aspect of cover cropping blocking light depends on the cover crop species as well, right? So you are seeing here in this infographic some of the possible changes, I would say, in the environment surrounding weeds as a result of actively growing cover crops. So you see a living cover crop on the left, terminated, and that cover crop residue on the right compared to that fallow you see on the center. So you see those changes that you are observing that are deep. The deeper the seeds, weed seeds are in the soil, the less pronounced is that change that you are seeing there. And all those colors here really indicating that dormancy or germination response to weeds. So let's see, The red text here, like providing habitats to seed predators or habitats for seed predator, you see here indicating really that inhibition, whereas the yellow text, for example, altering soil temperature, reducing nitrogen availability, those are all in yellow and indicate some variable response, meaning that depending on the cover crop species, you will see more or less of that effect. And the green text really indicating here that promotion of weed germination. So soil moisture, when you have soil moisture reduction, soil oxygen content increasing. And finally, that gray text indicating that neutral effect, that the cover crop is neither inhibiting nor promoting weed emergency. So as far as cover crop as a weed seed bank management tool, we see here that transition right from dormant to non-dormant, germination and establishment. So what are some of the promoters we see here in terms of cover crop altering the soil environment? We have increases in soil temperature in the spring from growing cover crops. We also see soil moisture increasing from cover crop residue, soil oxygen increases. All this affect the seeds from dormant to non-dormant to germination. Now, there are some inhibitors too that you see here. For example, soil temperature maximum is reduced, that soil temperature fluctuation, and the habitats for seed predators. So those are all the things that are happening if you think about growing a cover crop is not simply adding that to the system, but looking at a holistic way, all those different aspects that can happen just by altering the soil environment, whether it's a temperature or moisture difference, light interception, all this affect how the weed will emerge and the effectiveness of cover crops in suppressing weeds. Now, I want to highlight here some of the studies looking at cucurbits in which cover crops is often integrated in looking at more conservation tillage practices. And you see here in this table some attributes of an ideal cover crop or cover crop mixture for cucurbit production. A couple highlights here: the ability to produce high amounts of mulch, be easily established and suppressed or killing some matter, suppress weed growth effectively, and not interfere with crop growth and yield. So you see here study that was recently published looking at mustard interseeded between rows of pumpkins as a method to control weeds. As you can see here, the mustard is providing some significant competition to the pumpkin and even preventing the plant from finding out and maximizing the growth potential. So this is something to keep in mind, because when you're planting cover crops with your cash crop, there is that sort of competition for space and light that needs to be taken into account as well, right? Now, in terms of leafing mulch, especially in cucurbit production, those can really provide multiple benefits from ecosystem, right? Including reducing erosion, decreasing weed and pest pressure. But when we look at those leafing cover crop mulchings, there are some inconsistencies in terms of yield and even lack of best practices for weed and pest management, which really has prevented the wide adoption of those leafing cover crop mulching. So this is a really interesting study that I would like to highlight here that was conducted in Wisconsin, where they look at leafing mulchings. You see here white clover, annual ryegrass, and a mix of both. And compare that to full tillage cultivated ground and also straw mulch control for really looking here at yield, fruit marketability, weed and pest counts, and also weed management time. So looking at briefly at a result of the results of this study, you see here the figure on the left. we have total broadleaf and grass weed counts across different dates and subsample, and this study was conducted in 2018 and 2019. So we see here that across both years, the straw mulch resulted in lower weed counts than the other treatments, but except for the ryegrass here, ryegrass looking at grass weeds, where it kind of performed similarly. Now for the total and grass weeds, we see here that the clover had greater weed numbers than the other treatments, and the cultivated treatment here had the greater weed numbers than the ryegrass and the mixed species living mulch. And finally, you see here for the broadleaf weed numbers, they were similar among all the treatments, right? But despite the fact that there was higher weed numbers in the clover treatment, when we look at the graph on the right-hand side, it required less time for weed management than the cultivated isolate. So really showing here that the mixed species living mulch require also a similar amount of weed management time compared to the clover treatment, despite of having fewer weed. So really this study here showing the interplay not only of the weed emergence with cover crop adoption and living mulchings, but also related to weed management time, which is very important when we think about vegetable production, right? And finally, this study also looked at some of the cucumber beetle observations on those living mulchings. So you see here that certain living mulches species reduce pest and weed pressure. So we see here the straw showing the highest cumulative cucumber beetle, whereas the clover, ryegrass, and the mix, the lowest cumulative cucumber beetle. So this is, I like to highlight this study because it really shows the aspect of consideration for cover crop as a living mulch in cucurbit production, which overall we have been seeing that living mulching systems can be a great way to reduce pest and weed pressure. But one thing to keep in mind is the possible effect that they can have in yield depending on the species selection and also the environment you are working. All right, so now moving to the soil organic matter dynamics, I would like to focus here thinking about from a crop fertility standpoint. We know that integrating cover crop practices requires adjustments on the ER rates and application of fertilizer if you're interested in maximizing that vegetable production. So depending on the cover crop species, let's say grasses cover crop, you can have a high carbon to nitrogen ratio that can reduce your yield due to nitrogen immobilization, really require increased adjustment of that fertility program, right? So all those aspects of fertility management and looking at cover crop adoption, all the process that goes behind nutrient immobilization and mineralization, this all requires understanding of soil organic matter dynamics. And soil organic matter has been some of the work that I did prior to joining Ohio State too. So another quick analogy here when thinking about soil organic matter dynamics, it's thinking about where I am now, right? So thinking, let's say Columbus, Ohio, right? The home of the Ohio State Buckeye football team that has a population of about 1.3 million. Now, our football stadium has the capacity from what I saw online of about 100,000 people. So as you might imagine, during game day, there's a lot of people coming to Columbus, right? And as you can imagine, that population during game day gets way above 1.3 million. So I like to do this analogy because exactly that happened with carbon and nitrogen in soil organic matter. We want to know not only what is coming for game day, or what is leaving, but we also want to know what is sticking around. So exactly the same concept, we want to know carbon and nitrogen in soil organic matter that is sticking around for a longer time and can be used for feeding the crops, right? And more important than that, we want to know how we can differentiate between those that are sticking around and those that are leaving in an accurate way. So what is soil organic matter? There is we have seen some shifts in paradigms in how we see, how we quantify soil organic matter, which historically has been classified or understood in terms of humic substances, right? But more recently, we have moved on from that concept and are figuring out ways to describe and accurately quantify or predicting what is happening with soil organic matter. And one of the most recent and emerging views of soil organic matter, consider it a continuum of decomposition, right? That idea of a river, things coming together in that river, if you will, right? So plant litter, manure, but microbial products, all those molecules, right? And you see here in this river, in some places it goes faster, sometimes it goes slow. So those compounds are carried on in this river, and those complex molecules, they are chemically very different. And essentially what happens is they get respired out as CO2. So those microbes in the soil working to decompose those materials. So a couple of things here can change this flow, how these compounds move in the soil, right? That organic carbon and nitrogen taking up the microbes. So basically, they can be uptaken by the microbes. That is one way. Then can also be stuck to the minerals in the soil, and they can be physically protected. This rate from input to output is dictated by two main things. First, how well those compounds stick to the soil. And secondly, the efficiency of that microbial uptake and incorporation into their biomass. And you might ask me, how do we quantify that, right? How do we know those two main rates of flow from input to output? Well, in our soil science, we usually use the term particulate organic matter and mineral-associated organic matter. So essentially, your particulate organic matter is your checking account. So all those carbon, nitrogen that is staying in the soil for short periods of time and will be using by the microbes on their day-to-day activity. Versus your mineral-associated organic matter is more your savings account. Is that carbon, nitrogen that is staying longer to the soil? It could be used by the crops through longer periods of time. So I want to share here a quick study. When I was in Nebraska doing my graduate program, we essentially look at those different compartments of soil organic matter, if you will. We brought samples to the lab and we did a lot of soil fractionation to really try to extract those different pools of carbon and nitrogen in the soil. So you see here all the different compartments that we took, but essentially looking at those two main contrasting pools, right? The mineral associated and the particulate organic matter. So some results here that we look at, what are some of the gains in that carbon and nitrogen due to cover crop adoption? So really quickly here, I want to show this result for nitrogen in the soil on those different soil organic matter fractions. So we had in this study 4 main locations where we are looking at cover crop adoption for 3 years, how that affected soil organic matter. So we see that for the bulk soil organic matter, essentially here we were comparing 3 main treatments: that no cover crop, that cover crop site that has been adopted cover crop for 3 years, and what you see here in green, that reference soil. So what is that reference soil? Well, in Nebraska, we were comparing with grassland sites. But that really could be, for example, thinking here in Ohio, some forest soils, any soil that would embody all the principles of soil health, continuous living cover in the system. So basically, we see here that those reference sites, they had the highest nitrogen store in the bulk soil organic matter, but also on those fractions that I mentioned, that checking and savings account, right? So we see here the particulate organic matter also showing increases on that carbon and nitrogen. Here I'm showing nitrogen, but the carbon was very similar results. And finally, that savings account that I mentioned, that mineral associated organic matter, essentially we did not see any increases with cover crop adoption. And essentially for this study, we did not observe cover crop effect in the short term. That 3-year adoption that I mentioned was not enough to change that carbon and nitrogen store on both checking and savings account per se. And part of the reason is in terms of biomass production, right? We know that we need to have enough biomass, and in our studies, we were looking at below 27 grams per square foot of biomass. Now, in the same study, we also look at other management practices. So we had cover crop adoption, but we also have tillage and irrigation practices. And each of those soils, they had different texture. So this really allows us to see how all those factors might play, right? It's not simply cover crops, but are you using any tillage? Are you irrigating your crop? What is the soil texture? So what you are seeing here in this graph was looking at the declines or gains in nitrogen in different fractions on that checking and savings account. You see here the bulk soil organic matter, but also the different fractions. And what is showing here is that the highest declines in cropland relative to that reference soil were the highest in non-irrigated sites with coarse texture and under tillage management. So essentially, bottom line here is that soil fertility definitely changes according to tillage methods and cover crop practices. And there is also little information regarding how we optimize that fertilization rate in vegetable crops that we grow, particularly looking at conservation tillage practices. All right, getting towards the end here, let's look at cover crops and how that contribute to pest control by either supporting natural enemies, but this is not the only way that we can see that, right? Cover crops can also help to control pest damaging. So focusing only on the natural enemies really disregards some of the aspects that the plants can provide too, right? So this is a good segue here, looking at pests in cover crop adoption, which I like to say that the really missing piece here in pest control is looking at the soil health. So really that ability of crops to resist and recover from pest damage is closely related to soil health. So we know that healthier soils will have more plant accessible nutrients that will lead to healthier plants, and those healthier plants can fight diseases and pests on their own, right? So soil health, we know, can have more than a direct impact on pests through beneficial fungi that kill insect pests. Cover crops also improve soil health, which results in those healthier crops that can support robust predator communities that can help keep those pest populations from getting too high. So on the pest aspect, there are several soil-borne diseases that are often severe when we have poor soil conditions, and their presence is not only influenced by those inherent soil properties, those physical, chemical aspects, but also biological and climate and agriculture management. Now, what are some of the mechanisms for cover crop and disease reduction, right? So a couple of things that the literature has shown us in terms of the leafing mulching helping to reduce soil splash dispersal due to cover crop residue. There is also that increase in soil organic matter and microbial activity leading to a higher competition with soil-borne pathogens for resources. And also that microclimate, really looking back at the earlier slides that I showed you on how cover crops can alter the microclimate and the environment surrounding. So we also see that not only from a weed perspective, but also that microclimate modification providing some disease suppression. Now, getting to the end here, for those that are new to cover crops, remember at the beginning of the presentation, there was a fairly high percentage of those joining us here today that are new to cover crops. So let's practice. Let's see what are some of the tools and options available I'd like to share here. So first, if you are new to cover crop, a couple of things that I would consider is plan cover crops in advance, right? Like I mentioned before, I know it can be really hard to make cover cropping a priority in the midst of all the more pressing demands of a vegetable farm. So that's very important to plan those cover crops in advance. And perhaps the most critical first step, I would say, is becoming committed to a committed cover cropper for integrating that in your plan. And this means that when you decided where, let's say, your onions, your potatoes, your eggplants are going, you should also start thinking about what cover crops will immediately follow each of those crops in the rotation, or use it as companion plants, right? Like I mentioned before, there are some opportunities for those companion plants. I would also say if you are new, start small and build off what you learn. So a few beds on your field, a portion of your field, really start small so you gain confidence, you learn, and then you are able to expand and do more innovative things. So another important point, keep records. This is very important. I usually like to say what gets measured gets managed. So if you are able to keep records and really understand what is going on, you can adapt and change for the next growing season. All right, so thinking about getting started, right? There are a couple of tools available. One of the most famous cover crop tools, I would say, it's called Cover Crop Decision Tool from the Midwest Cover Crop Council. Some of you here in this audience might be familiar with it. This is really a great tool to start like looking at what are the options available for you, right? Now, I would be cautious when using it, particularly for if you are a vegetable grower, because most of the information and the things available in this tool are primarily focused on row crops systems. However, it's one good news is that they are expanding this too, and they will be incorporating also vegetable crops. So this can really help, hopefully in the near future, you really use this tool also for your vegetable crops. So I will show quickly here how that decision works. So basically you can look at it. As you can see here, they mentioned that for the vegetable crop, this is still under construction, but I will show quickly how the tool works. It's fairly simple. Essentially, you pointed here, where is your farm? And then you can add the county. So let me see. I will put Ohio. I am right now in Wayne County. Right here, and then goals, right? There is no one size fits all for cover crops. It really depends on your goals. What are some of the things you are interested in? So here are a couple of the goals that you could consider. So I will go ahead and select that my goal is to have cover crop as a nitrogen source. And then you can find cover crop. Oh, another thing that you can also, at this point, add your current cash crop. Like I mentioned, the vegetables is something under construction, but hopefully in the near future, they will be able to add more of that. But let's say I'm interested in adding nitrogen source cover crop for my warm season vegetable, let's say bell pepper that I'm planting in May 10th. Planning to harvest it on, let's say, July. So essentially, basically you see here all the cover crop options available for that particular goal, your warm season vegetables. Again, I would take this as with some caution at this point as they are still building on the vegetable side, but just to show you how the two work, essentially showing the highest ranking of the most adequate cover crops for the system. You have here your current cash crop growing period highlighted here, and you're able to see throughout the year what are some of the available cover crops. Again, this is a very useful tool that I hope the more we get inputs, information in the system in terms of how that works for vegetables, I'm sure this will be a very useful tool for growers. Now, before I finish, quick question here. If you are new, if you are experimenting with cover crops, what are some of the things you will be interested in trying out? Any general thought that you want to share here? If you can please scan this QR code again, and we'll take you to the question. But really trying to learn here, what are some of the things you are interested in? Let me see, perhaps now we should be allowing you to answer. But yeah, and before that, I just want to share some resources here. Feel free to continue adding here any thoughts or ideas if you're interested in experimenting with cover crops, what you would be interested in trying out. But my next two slides essentially has a couple of resources that you could considering. One of them is managing cover crops profitably, publication by SARE, the Sustainable Agriculture Research and Education. Also, cover crop selection for vegetable growers. There is that University of Minnesota Extension publication, and all this will be available. I'll be happy to share the presentations here. Also, some best practices for sustainable urban farm. There is a really nice SARE publication that recently put out some of those practices for sustainable farms. And finally, new entry sustainable farming project is also something I would consider taking a look at. And all those are available here. And one last announcement for those interested in urban food systems. We at Ohio State will have the Urban Food System Symposium this June. So the registration should be opening soon. Really inviting everybody here interested in attending. The main theme of this conference will be developing urban food system for sustainable and resilient communities. So there is information here on the QR code, and our registration will be opening soon. So be glad to have you here in Ohio and really seeing what is going on in terms of urban agriculture. So with that, I will thank you for your time. I appreciate the opportunity to be here today. We have a couple minutes for questions, but like I said, I am happy to connect after today, either via email or any other way that I could help on your cover crop journey. So thank you so much. And I will leave here just to see if we get any other responses. But yeah, it seems weed suppression, weed control is something that folks are interested in. Trying that cover crop tool looks like a great resource. Awesome.
Yeah, so if anyone has questions, you can put them in the chat box if you'd like, and I'll keep an eye on that. Sorry, I think my audio is a little funky here. Apologize for that.
I can hear you. Yeah.
Okay. So chat box, or you could also unmute to ask your question if you'd like to do that. And while you do that, I'll get us started. Fernanda, can you talk about the importance of finding a cover crop that's either winter kill or making sure you have a way to terminate that cover crop? Because I think that's something that is sometimes overlooked by folks, and then they have a weed problem that comes from their cover crop.
Yeah, that's a really important point. You don't want that cover crop to become your weed, right? You want the cover crop to suppress your weed. So there are a couple things you would really be interested in looking at those species that are winter kill. So there are legumes, you can think of hairy veg, there are oats. Those are some of the most common used ones that are winter kill. Now, termination methods, there are different ways to look at, and also depending on the space and the machinery you have available, right? But using tarps for cover crop termination is one way that I have seen growers using it. Now, if you have a bigger size, I have seen a roller crimper as a way to terminate that cover crop, which if you are in a less than an acre, half an acre field, I suspect there are opportunities to even looking at your regular mower and like terminating that. Essentially, that's what the roller crimper will do, the machinery, but this is an opportunity to consider.
I was going to add to that, Fernanda, that in our high tunnels in particular, we use the flail mower.
Flail mower.
Which
yes.
really, I mean, it depends on the crop, right? But it terminates
Yeah.
it and mulches it very well right on the surface.
Awesome.
And that goes on our BCS, like walk behind machine.
Yes, that's a great point.
James in the chat box kind of added to that chorus that they bought a winter kill cover crop, but they're growing in a high tunnel. So the winter kill, you know, is flexible depending on those in tunnel temperatures. He said that they're mostly dying off now, but some are still kicking. So how do I know when to manually terminate the cover crop?
That's a good point. Well, it all goes back on the goals that you are interested in as well, right? If it is a weed suppression, you want to have that biomass production. Now, if it is for a pollinator habitat, you will want to have that cover crop grow to flower, and consider that for in terms of when to terminate, right? So it really there are a couple of things in take into consideration here. One is what are the initial goals? Why you establish that cover crop? We can really help to dictate some of that termination window, but also the environmental conditions itself. If you are not talking about protected agriculture, right, open field, then certainly that frost kill days are important and will certainly dictate that natural senescence if we were talking about a winter kill cover crop.
Right. Carol in the chat box was wondering, is buckwheat one of the better cover crops for creating better soil texture? And do you need to cut it before the seed heads form?
Would you mind repeating the question, Maggie?
Yeah, it was about buckwheat
Mhm.
as a cover crop. Does that one contribute to better soil texture? And do you have to cut it before the seed heads form?
Yeah, so I suspect the soil texture aspect here is more thinking about like soil aggregation and how much that soil particles are together, right? Certainly, that's it's important that the root system, I'm not completely familiar. I would need to look at more in details on like the root system of buckwheat, because that can certainly help to understand what the benefits that buckwheat can have on as far as soil aggregation. Now for determination or cutting the heads, I have seen buckwheat use it also for pollinator habitat. So we would also consider that that flowering period as important on that aspect.
Yeah, I'm looking it up on the tool right now. I'll let you know if I find anything. Ada, it looks like you have a question. You're unmuted. Maybe it's by accident, but I just thought I'd give you. Do you have a question, Ada?
No, go ahead. And there's a little bit of stir fry in there.
Okay, no question for now. Who else? Anyone else have a question for Fernanda? The thing I get from your presentation and all the research you presented too is just that cover crops are so complex that it depends on your goal. It depends on the cash crop you're growing. And that you really have to do your research before jumping into a cover crop.
Yes, and the sooner it start, the better, right? Putting that in your plan, because I know, like, looking at a vegetable farm, you have lots of other demands just by growing your main crop. So I know it's hard to, how do you squeeze the cover crop on that? But there is certainly a lot of benefits and a lot of unknowns still that would be interesting from a research perspective, those are interested in trying. But yeah, I appreciate the time to be here today. And again, feel free to reach out to me if you have any questions or like to talk more about it.
Yeah. I used the crop tool real quick and it said buckwheat was ranked as a #2 for soil building, which ranks it as good. So this tool is very informative.
Yeah, it is. And hopefully in the near future, we'll have way more capabilities in terms of the vegetable production, which is still like, it seems under construction, like the system behind. But the more and more people are interested in the practice, I'm sure there'll be opportunities to feed some of research data in the back of that tool that people can use to make informed decisions.
Absolutely. I'm seeing a lot of thank you. Yeah, lots of great information.
May I ask a question?
Yeah, please.
I'm not sure if there's a good answer here because every climate is different and weather is, different everywhere, and there's no real way to predict that. I'm in Indiana. We've got a high tunnel. We're growing like a 8 species cover crop mix with radishes and wheats and grasses and peas. We want to plant for our mixed vegetable farm starting in like March. I've got some stuff, like I said earlier, that's starting to die off with the freeze that came through, but a lot of it's still kicking. So I'm thinking that I should start considering putting a tarp over it or manually terminating it. And wondering, is now a good time to do that so I can get maximum production for spring growth? And any idea on how long it takes for that residue to die off with the tarp over it so it starts breaking down? I think for like some crops, sorry, I know it's hard to answer that. For some crops like tomatoes, I can move the residue out of the way and plant, the peppers and tomatoes down into it and leave it as a mulch. But things like lettuces and stuff that I'll direct seed and spinach, that gets a little tricky, and I want to make sure we've got beds that are clean to plant into. Thank you so much for this presentation.
Yeah, that's a very great and comprehensive question, James. I will need to do a little bit more of a search and come back to you on like more of the recommendation on that. I know like tarping is an option. Now, if you were adding lettuce or leafy greens on that, perhaps you would want to do some sort of incorporation of your residue, of your cover crop residue, right? And also it might perhaps really require some, depending on the species, if you have grasses and how much of that grass is growing that mixture, you might want to be cautious about any nitrogen immobilization in that soil and consider even applying some compost or organic fertilizer that could help breaking down that residue.
Yeah, and that brings up a really good point too, because your planting methods also matter when you're talking about those termination tactics too, because if you're putting in transplants, you have the ability to leave some residue and potentially that living mulch. But if you're heading towards that seed, direct seeding, and you do need a nicely prepared bed.
Absolutely, yeah.
And I know people have experimented too with also how small of an area do you have to till to put those seeds in and to let those seeds germinate, right? Maybe you don't have to till the entire area. Maybe it's just I don't know what the terminology is for it, but like a strip, tilling a strip instead of.
Yeah, yes. And actually that one of the studies that I showed at the beginning of the presentation is actually like looking at a strip tillage aspect where you have leafing mulch and really just have the area where your cash crop is growing as the area for seeding or transplanting.